Okay, now we're actually asked for the magnitude of the EMF, the induced current, or sorry, the induced voltage here. Again, we solved this on the last problem, but I'll just do it again using Faraday's law here. So the induced EMF is just the minus the change in flux with respect to time. And so that's the derivative with respect to time, and the flux is just the area of the loop, the magnitude of the magnetic field, and times the cosine of the angle between those two, which I'm writing as omega t here since it's rotating. And when we do that, I'm going to get a minus the area, the magnetic field, pull out an omega, I get a sine of omega t. We're not going to worry about if it's positive or negative since we just need the magnitude here. And so the one thing I do have to worry about is what is this angle, omega t here. And they say we're going to have it rotated into the YZ plane. So again, forgive my drawing here, but it's basically rotated 90 degrees from where it is now. So if I kind of draw a profile of the loop when it's rotated, then the area vector associated with that would be in the x direction, either positive or negative x direction depending on how we define things, but it's going to be in the x direction, which is going to be 90 degrees rotation with respect to the magnetic field that's coming out of the page. So I'm just going to drop the minus sign there just because we only care about the magnitude. So the area of the circle, the magnitude of the magnetic field, the rate at which we're rotating it, and then I have the sine of 90 degrees, which is just 1. So the area of the loop is just going to be pi times r squared. The magnetic field, they told us, is it's just b and omega. They've also told us, so I'll leave that there. Plugging numbers in here, I get pi r, oh sorry, I should use small r here because it's the radius of the loop. I want 5 centimeters, so got to be careful to convert that. Magnetic field is 0.75 Tesla, and omega is 38. When I plug all those numbers into my calculator, I get 0.224.